I can switch it up at any time and talk about beer. That's not a problem. These are model doubles, by the way, not my wife and I. Honey, is it cold in the room? My cue to get up and get another blanket. My point here is that human temperature perception is really not very reliable. And when you talk about the history of weather events, it's even worse. For instance, if I ask you, did it snow real bad when you were a kid? You said, yeah, I got out of school. Well, give me some numbers so I can compare and see how bad it really was. Would you see this movie if this weren't happening? Hollywood doesn't get climate or weather or science right. Hardly ever. Bad science or no science in this movie, and the timescale of climate change was all wrong. It maybe got some people to think about it, but we have some problems. So here's the thing. Climate is not sexy. There are no gunfights or car shootouts or anything in it. It's numbers over long periods of time. And the problem with it is that's the problem. To get people to react, it doesn't just hit them in the face. Climate is more than just one storm or one hot summer. So we're going to have some issues here. Tortoise and the hare, everybody knows the picture and the story. And if you're comparing weather to climate, then you're looking at this story. Weather is the hare, moving very fast, changing day to day. Climate is the tortoise, and the tortoise is supposed to be the more boring story, right? It's moving very slowly, but before you know it, it changes. Now, yin and yang here. Take a look at this. When you talk about climate change and you're talking about warming, you're talking about positive and negative feedback. So if it's a positive feedback, it adds to the warming. If it's a negative feedback, it takes away. An example, if your deforestation process, you're taking away, our carbon dioxide sinks. So you're making it worse when you chop down the trees. The greenhouse effect, of course, that's a natural process. It keeps our planet about 60 degrees warmer than we would be normally. Carbon dioxide and water vapor are the two primary greenhouse gases. And of course, the main question is we're adding CO2, anthropogenic changes. Are we adding so much so quickly that we are going down a road that we can't reverse direction on? Is it warming? No question. Here's the temperature graph since the late 1800s with the median line, the black horizontal line. You can see the warming occurring toward the last couple of years there, especially over the last couple of decades. And I know that just by personal experience watching the weather. We've broken more records in the high side than we have on the low side. Now that is the Mauna Loa carbon dioxide output, steady increase. Sure looks like a smoking gun to me. I can't discount natural climate change, but that's something that has taken everybody a real double, triple look at. And of course, there's a lot of unknowns in climate change, a lot of variables. Water vapor is one of them. This is an image that not just shows clouds, but the vapor in the air. It is a positive feedback because it's a greenhouse gas, but it's also a negative feedback if it produces a lot of clouds and reflects sunlight. So climate modelers are always looking at that. And by the way, if there's more water vapor in the atmosphere, the theory is that we just get more juice out of the systems, more rain and more snow. Okay, Hurricane Sandy. It took a bad left turn at a horrible location. Now, that has nothing to do with climate change. Now, the question we have to ask ourselves is that storm at that latitude, was it a stronger tropical system? There may be some evidence to support that. Of course, it's always about where it hits and how bad it is, human population, human response. The jet stream is also connected to climate change. If the climate goes the way we think it will and it warms, the jet stream should get weaker. Now, the jet stream drives mid-latitude and high-latitude storms, non-tropical. If it's weaker, those storms should get weaker. So I think what might happen is we'll get less of the non-tropical storms, but all the storms will be a little bit juicier. Now, climate modeling, that's when you stick all the variables into computer equations and you stick out and you're waiting for an output over lots and lots of years. Lots of unknowns, lots of speculation about it. However, interesting point, how do you know if something is running past your lifetime if it's working? You take the old data, stick it in there, and if it predicts your present correctly, then you're probably onto something. Now, fresh water melting. We have, of course, a lot of fresh water in glaciers, and of course the Arctic and Greenland are positive feedbacks to warming. If that were to melt, we wouldn't have as much albedo or reflection of sunlight. That would also change the weather patterns up around the North Pole as well. Greenland is one we should take seriously. It looks like maybe we've had a sea level rise of about a ½ inch due to melting so far and the warming that we've had. If the Arctic ocean ice melts, it's bobbing on the water, so there won't be that much of a change. If this goes, we're talking about 20 feet of rise. And by the way, Antarctica would be a big player, but it's a lot harder to melt down there. The southern hemisphere is a very isolated weather system. Adaptability, classic picture here. is it happening too fast for plant and animal species to adapt? And that's a huge, huge question, and one, again, which we need to be taking very seriously. Will we? And then part of the problem is political as well. Taking a look at fossil fuels, and when you burn them, you're doing two things. You're producing carbon dioxide, but you're also producing aerosols. Carbon dioxide is a positive feedback. Aerosols are a negative. They reflect sunlight or they produce clouds, which are better at reflecting sunlight. So it's possible that the aerosols have been a mask to global warming. When we do the polluting, we're also producing something that is kind of working against it. Look at the landmass in the northern hemisphere. Russia and Canada, all climate models predict that the higher latitudes will be warmer if there isn't as much Arctic ice, or if it's gone, more humidity is available. Dr. Cliff Mass of the University of Washington says that we are going to do the experiment and we're going to use the planet as the laboratory. It's a very pessimistic view, but I think he happens to be right for several reasons. Number one, we can't get a global commitment and stick to it. Number two, can we reasonably ask China, India, those places to not do what we did, and can we enforce it? And are we making lifestyle changes? Here's what he thinks we ought to do. He says, let's just take a look at the climate models and try to be reactionary, try to figure out our infrastructure, try to deal with population and political issues. Resilience and adaptation must be holistic. Global warming is a big problem. That's one of my favorite pictures ever. Tom and Jill and myself, we had a warm relationship, but as the image indicates by my frozen tongue stuck to the pole, it was starting to get colder. The current climate change in broadcasting is Ice Age for me. Thank you.